Extension mystery. John, say something.
Something.
Okay, good. Now we're done. That's the mystery John is going to present today, ladies and gentlemen. We've got a huge crowd. I don't think we can pronounce the official number of people attending, but just imagine you are a couple of hundreds at least. It will make you feel better. It will make you part of a huge crowd that attending this groundbreaking webinar.
Right then.
So, Emmy, will you kick off the official moment of
the official moment? Yeah. So first of all, welcome everybody to this meeting of the In Memory virtual chapter, and please welcome Nico, which is our new co-lead for this group. Woohoo! Yeah, congratulations, Nico. Welcome. We're all very happy to see you here. And today we have a fascinating session for you. By the way, why don't I see the screen? Do you guys see it?
I see the screen. It looks great.
Yeah, I see my screen. I don't see. But if you're, I'm not really important. It's more important that you. Oh, okay. Now it's back. We're good. So. Yeah, I think we can start, right? The people didn't come here to hear our stupid jokes. So let's go right to John Martin, Premier Field Engineer, or as his nickname, PFE at Microsoft, the Great Buffer Pool Extension Mystery. And go ahead, John. The stage is all yours.
Thank you very much. Hi everyone. As I said, I'm John Martin. I'm a Premier Field Engineer for Microsoft, so PFE, specialising in SQL Server. I'm also help run the user group in Southampton on the south coast of the UK, and generally try to do a bit of community stuff here or there, speaking and helping out at events. So, what are we going to be covering today? Well, as the title says, the Great Buffer Pool Extension Mystery. What we're looking at here is great feature, came in with 14, but not many people know about it. Not many people understand what it is, how to use it. So hopefully we'll look to try and address a few of these things. Okay, so what are we going to be covering? We're going to be looking at, say, SQL Server 2014 buffer pool extensions and how to use them, what it is, how they work, and when and how to use them. When we look at some of the elements that ship with the product as well that it works well with, so the amount of pressure that's coming into the buffer pool and how the memory space has changed with SQL Server and generally computing in general. So, without further ado, next slide. Here we go. So, what is buffer pool extension, I hear you ask? It's, as I say, a new feature. It was introduced with SQL Server 2014. It is available in Standard Edition and above, so it's not enterprise only. There are some restrictions surrounding it with regards to Standard and BI. The limitation being 4 times the maximum amount of memory that you can fit, or basically allocate to the SQL Server. As a result, because there was the uplift from 64 gigs of RAM to 128 in SQL Server Standard 2014 Standard Edition, what you can do is essentially have a ½ terabyte of buffer pool extension. It's all well and good, but what is a buffer pool extension? I can have ½ terabyte of it. Well, essentially, it's designed to act as a level 2 cache for the buffer pool. So if you think of the way that CPUs have multiple layers of cache, so you've got a level 1 cache, level 2 cache, and level 3 cache, and they're varying degrees of distance away from the CPU and the processing. The closer it is to the CPU, the faster it is. Now, it's a file that you can materialize on storage. Local storage, you can materialize it on any disk format, but it's been designed ideally to be placed on something like PCI Express flashcards or SSDs. Okay. Now, what it is, it's a logical extension to the buffer pool, and we've got some slides. We'll have a look at the sort of structure and sort of layout and how it all fits together in a sort of logical way. And then we've got some demos further on to into the session where we're actually going to have a look at it and just see what happens when we use it and how it works. So as we go through this, feel free to pop questions into the chat window, and I'm sure we'll either sort them out towards the end, or if they're kind of pressed, I'm sure one of the other organisers will jump in and ask the appropriate question at the appropriate time. So, why buffer pool extensions? It's geared and aimed at OLTP systems, where you've got really sort of a read bias rather than a write bias. Sorry about that. OLTP generally sort of gives you random I/O into the storage subsystem, picking out small pieces of data lots and lots of times. So when you think about it, you go in and you're getting a couple of pages here, a couple of pages there, and they're all getting stored up in memory in the buffer pool, the cache for SQL Server, if you will. And over time, obviously, you get more and more you accrue data in there, and this is our page life expectancy number. Now, with that, what we have is when we reach a certain point, basically the buffer pool gets full and we try to add more data, it has to evict data from that. Now, if we haven't got that much memory in comparison to the amount of data that we're churning through effectively, what this means is that if we evict a page and then we want it again, we have to go back to the disk subsystem and bring it up, put it back in memory, and in order to do that we have to evict another page. So with memory being one of the smaller components in a server these days, okay, yeah, you can get servers that are, I mean, some of the newer servers will handle up to 6 terabytes of RAM. Windows Server can address 4 of that. But in some of the smaller sort of 1U, 2U servers, you're typically looking at maybe a couple of hundred gigs of RAM at most. I obviously appreciate that some of them are now getting up into the larger realms. But again, if you look at something like Standard Edition, you can only address 128 gigs of that. In addition to that, we're looking at the memory space change with SQL Server. Between 2008 R2 and 2012, the memory architecture was changed. We went from having 2 memory allocation systems, a single page allocator, which was essentially the buffer pool and a few other things. We had the sort of multi-page allocator where we're allocating CLR and stuff like that. In 2012, we changed that. We have an any page allocator. So everything that needs memory talks to that. So whereas prior to sort of SQL Server 2012, when you set the max server memory, you were essentially setting the buffer pool. Okay, you do that in 2012 and above, and you're actually setting the vast majority of the SQL Server process space. So what this means is that if you were to come from, say, SQL Server 2005 to 2014, for the same max server memory settings, you're potentially going to have a smaller buffer pool because there's more things looking to try and take that memory space, especially when you consider some of the new features that we've added as well, which we'll cover shortly. And then we have a physical limitation of memory. As I said, in 1U servers, if you build a SQL Server with 1U box, potentially you're looking at limits of the amount of memory that you can fit in there. So even with Enterprise Edition, you can only physically put so much RAM into a server. In which case, it is also possible to look at adding PCI Express flashcards or SSDs to it to give you some high-speed storage. But again, is there going to be enough space for that will fit all of your data? Potentially, potentially not. Okay. So, I mean, we're looking at, like I say, OLTP I/O patterns where you've got the read bias, a memory contention where you've got a lot of things vying for the memory that we've actually given SQL Server, and then the physical limitation of how much we can actually fit into a server. So, leading on from that, and where I said we've got these contention issues, if you will, between the buffer pool and everything else that is after a piece of that memory. So, what do we have here? This is max server memory as of 2008 R2 effectively. Buffer pool, nice and big and happy all on itself. Going to eat memory, not a problem. Once I've got it, I'm not giving it back. However, post SQL Server 2012, we're also allocating CLR into that memory space. Our buffer pool gets a little bit smaller. Column store. Yeah, takes up some memory as well, and obviously more memory that's going to take up, we're going to see buffer pool shrinkage there as well. And then when we look at the big headline grabber in SQL Server 2014 in-memory OLTP, every piece of data that you add to in-memory OLTP tables, be they durable or non-durable, is going to reside in memory. That memory is going to be taken from the buffer pool. So what seemed like a nice big buffer pool to start with originally, it's now shrunk down to something that's something a little bit smaller. As we see there, if you're making use of the various different features, we can put a lot of pressure on it. So how does buffer pool extension work for us? That's how. It basically gives us a mechanism whereby we can logically extend RAM with this little file, or not so little file as the case may be, placed on something like an SSD or a PCI Express flash card. So, put it into how do we look at it another way? SQL Server 2012, we've got our memory, relatively small compared to our overall amount of data which we've got on our storage platform. Now, that's the default out-of-the-box configuration for SQL Server 2014 as well. However, by enabling it, what we do, we add this little piece in. We add a third tier to our storage mechanisms effectively. So memory is where we're dealing with our level 1 cache. That's where our really high-speed access is done. And then we've got our SSD. It's still very, very quick. Very, very rapid at all. But it's a little bit slower than RAM. It's a bit further away. You're going to have a slightly higher latency. Okay. Now, we say SSD here. You can put it on any storage medium you want, but you will not get the performance benefits unless you do so. So even if you put it onto something that is pinned into the flash tier of a SAN, you're going to introduce the latency because you've got to traverse basically the storage fabric. Okay. So if you put this really, really closely, we're talking local storage. Now, this will work for things like clusters, so you don't need to put it on shared storage, much the way that you can put TempDB down onto SSD storage as well when we look at and are dealing with cluster environments in an effort to try and get the data closer to the server to make it process it a lot quicker. Okay, and like you see there, buffer pool, that's where the extension sits, and then we have the data files. So obviously if we're querying, imagine the query coming in from the top, the memory is going to be the first thing it hits, it's going to be the quick. SSD is still there. There is a mechanism, we've got a diagram later on that I will sort of talk through as to how it accesses the buffer pool extension, but again that's going to be rapid, and then finally it goes down into the data file. So how does it work? This is one of the important things to understand. The buffer pool extension will only cache clean pages. So what this means is essentially that if it fails, you're not going to lose any data. And that's the whole point. Because you're putting it onto what could be considered an unstable or unreliable medium, for something that is effectively very, very integral to the way that SQL Server works, we only really want to cache the clean pages because we can afford to lose those. We can just afford to lose a chunk of data from memory. We've got it hardened on disk. It's persisted in our data files. It just means we have to go and retrieve it again. Now, data pages don't get put in there straight away. They're effectively evicted from the buffer pool into the buffer pool extension. We still have the LRU algorithm going through, evicting pages based around how old they are and how hot they are. So basically you've got hot pages, warm pages, cold pages. Okay, and once things are into the buffer pool extension, they're pretty much going to stay there until buffer pool extension gets full. Things need to be evicted from there. Again, similar principle kicks in. Or if you make a change to one of the data pages that exists in the buffer pool extension. In that situation, it will retrieve the page from the buffer pool, place it back in the buffer, make changes, put everything into the transaction log that it needs to, and that'll be fine. If you query a page that is in the buffer pool extension, you will not elevate it back into the buffer pool. So just bear that one in mind as well. Okay. And when we set the buffer pool up, it's got to be the same size as max server memory effectively. So it's got to be able to effectively say, okay, I've got nothing but clean pages, and now I can put these in here. So that's the type of that's the way to view it. So you've got, say, 8 gigs, 16, 32 of max server memory configuration there, the amount of memory that SQL Server is using. what you do when you create the buffer pool extension, it has to be a minimum of that size, if not larger. Now, when it comes to our recommendations about sizing, we're talking between 4 and 10 times the size of memory. Okay, there are some limitations to it. As I said, we're looking at 4 times the size of maximum memory for standard edition, so we're talking about half a terabyte there, and the limit for enterprise edition is capped at about 8 terabytes. Okay, so if you've got 8 terabytes of local flash, yeah, but in that situation, you're probably using a lot of it for your storage as well. Okay, so as I said, here's a diagram. You want to issue a query into SQL Server. Okay, comes in through the standard protocol layers into the parser, optimizer, executor, and then it gets handed off effectively to the storage engine. Now the access methods will decide, okay, where is the page? What do I need to do to get hold of this thing? Now if it's not in the buffer pool at all, or the buffer pool extension, it's going to go to disk, it's going to place it in the buffer pool, and it's going to return you the value. However, if it is in the buffer pool, it will go and retrieve it from there. Now, when it does the retrieval, if the page is in the buffer pool or the buffer pool extension, doesn't matter, because what it does is effectively does a write-through, a read-through. So it's just a more memory address space. So as you can see in this diagram, the access methods and the buffer manager and the storage engine, basically they communicate with the buffer pool, and the buffer pool itself goes down into its level 2 cache, basically, which is where we've got our buffer pool extension. So hopefully this is all making sense. Now, when you turn it on, it's a server level configuration setting.
John?
So, yes? Hello? Right.
I think we're good to go.
Ah, yes. Okay. Not a problem. Sorry. Okay, no problem. We'll continue then. So yeah, turning it on, it's an alter server configuration setting. Set buffer pool extension on. Tell it where you want the file, how big the file is going to be. Simple as that. Okay. So, okay. Right. So when are we looking to use buffer pool extensions? When other engine features are in use as well. So we've spoken about in-memory OLTP, column store, things like that. Because when if you look to use in-memory OLTP, everything is hardened and persisted. Okay, for durable tables, we've got an element of transaction logging going on as well, but all of the data resides in memory. That's where all the indexes reside as well. There's a background thread for in-memory OLTP that will be streaming that down to disk, but that is still taking the memory space that potentially your buffer pool will be taking, or would like to take. So the more data you add to your in-memory tables, and the larger they get, the less space you're going to have for your buffer pool extension. Now obviously, we recommend you try to put as much memory into the servers as possible, but there's always going to be a potential need for that little bit more. So, in this scenario, you put your SSDs in and create your buffer pool. Is the server physically constrained? Now, it might not be physically constrained. It might be a case of, yep, we've got some extra RAM slots, we've got some DIMM slots in the server. However, our purchasing process takes weeks to actually get the stuff on site for us. In which case, if you've already got SSDs in the server, then look to just basically implement this as a short-term measure to give you that capability and capacity that you need over and above until your physical memory turns up. But also as well, when we look at things like SQL Server OLTP performance for things like page I/O latching, if you've got a very low page life expectancy, that means you're driving quite a lot of I/O just to maintain the standard sort of query performance of the system. So if you potentially you're preserving, say, 50–60% of your I/O channel, again, buffer pool extensions can help. They can hopefully have some form of positive impact. Now, the question I've been asked a number of times is, well, why would I put SSDs into my server and then put the buffer pool extension on it, rather than put SSDs and then put my data on it? Yeah, it's a valid question. If your workload profile doesn't sort of lean towards using the buffer pool. So if you've got a very write-intensive workload, yeah, you're going to be better off putting the SSDs in there and running your data files on them, transaction logs as well. However, if you've got the heavy read workload in your LTP environment, because when you're down in the storage engine, you're basically traversing the B trees and what have you. So you've got to do the data access through all the data structures. Now, the buffer pool is, when we talk about the terminology here, we're talking about a buffer, which is essentially your 8K page. And then you've got arrays of these. So you don't have the full B tree structure up in the buffer pool. It's built up of buffer arrays, essentially. So the access pattern is slightly different. Okay, and obviously if you're accessing data that you've accessed before and it's part and parcel of, say, lookup data that's within the system, obviously you don't want to be going down and traversing the index all the time. You don't want to be going down into the system and having to scan, say, heaps or do table scans, range scans, that sort of thing. Now, obviously, that logical structure that you have in the buffer pool is then mirrored down in the buffer pool extension as well. Okay. So the data access patterns are slightly different, and they're sort of optimized really for what they need to do. So that's when you think about, well, I'll just put the SSDs in, I'll stick all my data on it. You're still going to be performing more I/O than if potentially you've got that data there already in a warm cache. Okay. So moving on, trying to get my slide deck to work. Now we want to monitor and manage it. Okay, we've got a number of extended events in the system, basically to track evictions and what have you within the buffer pool. We'll have a look at those in the demos as we move forwards. We've got a number of DMVs. Okay, we've got one specific for buffer pool extension, which is the OS buffer pool extension configuration. Basically, this just tells you what state it's in, it's on. We've got a file, and this is roughly how big it is. If you want to find out the composition of it, then we're going back to our old friend DMOS buffer descriptors. Now, the DMV itself has changed. It's had an additional column put onto it. Now, this column is in buffer pool extension, or is in extension. We'll have a look in a moment. I forget the exact name of the column. But essentially what that allows you to do is identify all of the pages that exist in the buffer pool extension and all the pages that exist in the buffer pool. Now, because we can link that back to the databases, you can actually find the composition of the databases in your buffer pool by database very, very easily. And that's one of the things we'll have a look at, and as we start doing some of the demos in a few minutes, we'll have a look at those as well. And then we've got some dedicated perf1 counters. They're within the SQL Server Buffer Manager because that's the portion of the system that manages the buffer pool extension as well. Okay. Now we're looking at this for the amount of page reads, writes, evictions, outstanding IOs, free space as well. So you can monitor that with perf1. So if you're using things like System Center and you're using the buffer pool extensions via the perf1 counters, what you can look to do is incorporate that into your overall monitoring strategy. Okay. So now we have, it says demo, we have multiple demos. So bear with me 1 second. Oh, not questions yet. Thank you. Hello, Management Studio. Right. Okay. So we've got a number of demos here for us. What we will do is we will start off by enabling and disabling the buffer pool. So give me a second for this to start up. Okay, now we have a number of states that the buffer pool can exist in that we have up here. Now we just make the fonts a little bit larger for us here. No. Fonts. Okay, make it a little bit easier for us. So, state of 0, buffer pool is disabled, extensions are disabled, sorry. 1, it is turning itself off. 3, it's turning on. 5, it's enabled. Don't ask me why there's no number 2. Okay, so what we'll do here is we want to, like I say, it's alter server, it's a server configuration option, set the buffer pool. Right, execute that. Okay, right, didn't work, why not? Okay, Okay, buffer pool extension size must be larger than current memory allocation threshold of 2 gigs of RAM for the buffer pool extension is not enabled. Okay, so that's just a first example. That's me trying to basically create the buffer pool below the max server memory size. So, as we've seen, memory allocation threshold is 2 gig, but obviously we can double check that. And here we go. Yep, value in use, 2 gig. So what we do, we will come down here and we'll say, right, okay, I'm going to create an 8 gig file. Now, I'm going to create it on my E drive, and just there we go, 8 gig file. So, let me just grab my E drive. Here we go. Nice empty folder. Now, just so you're aware, that is a USB stick for the purposes of this portion of the demo, because what I'm going to illustrate is just how resilient this system can be when we're looking at doing the querying. Okay, so as you saw, no tricks, nothing up my sleeves. We've got an empty directory. I will now create our 8 gig file. That was nice and quick. There is our 8 gig file. Now you'll notice it takes up a little bit more than 8 gigs, but that's because of the way that the data structures are configured and set up within the file itself. Okay, so if we just look at properties, again, 8 gigs on disk. Nice and happy there. Right. So, what does it look like once we've got it configured? Here we go. We look into our OS buffer pool descriptors, extension configuration. Find out, there it is. Bring that up. Zoom in, have a look, so you can see the current size. Just make that a little bit larger for us. So we've got the current size in kilobytes, we've got our state, we've got our file ID, there's our path. So we can find out where it is, how big it is, what state it's in. As you can see, clean page caching is enabled. Okay. So, what do we want to write? Let's just run up perf1. So, performance monitor. We'll get rid of that. We'll add some counters now. Find SQL Server Buffer Manager. Here we go. So, we've got our buffer cache hit ratio, we've got our usual array of counters, and here we are, we have the extension counters. So if I add those, so we'd see free pages, allocated pages, extension in use as percentage, like I said, and then we've got evictions, reads, writes, unreferenced time, and outstanding I/O. Okay. In addition to this, we will I'll use the proper one. So buffer node, page life expectancy. Even though I've got a single node, we'll keep an eye on all instances. Okay. So there's a nice graph that doesn't mean very much, so let's have a look at a report. So as we can see here, we've got it enabled. Excuse the bad red line, but you can see how many free pages we have available to us. Okay, and there's our page life expectancy at the moment. Okay, so I conveniently have a query here. Now it's a nice big scan. I'm just going to read a huge pile of data. I've got basically a 6 gig table here, so I will kick this off. If I'm looking in the right database, how does that help? There we go. So that's just going to scan data away quite happily for us. And what we'll do is we'll have a look at our buffer pool composition query. So as you can see, we've got DMOS buffer descriptors that we're going to query on. If I just quickly just do a quick select star. Just so we can see all the columns we have. Now, here's the new one. There we go. Is in bpool extension. 0 means no, 1 means yes. So at the moment we haven't got anything in there. Like I say, we've got our database ID column. We can figure out which file it's from. We've got page IDs, page levels, allocation. We've got page types. We understand how many rows we've got in, how much free space. We can check, obviously, dirty pages and stuff like that. So if we're looking at our normal buffer pool behavior, there we go. So what we'll do is have a look at this. So what we're doing here is I'm just taking a timestamp, because what I tend to do when I do things like server migrations is use a query like this to basically understand how the buffer pool is being used by each database on the server when it comes to doing migrations, so that if I'm going to do consolidations, if I'm going to do dispersals, that sort of thing, then I end up in a position whereby I can get an idea of what's going on. But it's also very useful to understand what's going on with the buffer pool extension. So what we're going to do here, we've got our resource DB. We've got our in pool extension, so if it's 1, it's going to say extension. If it's not, it's going to say memory. We're going to count the number of pages that we've got and convert it down into megabytes. And then we're going to have a look at databases so we can tie it back to our database. So run that. Here we go. So far my little query has loaded approximately 1 and a bit gigabytes, just under 1.5 gigs of data into the buffer pool. So if we execute again, we should see that number pop up. Yep, 1.6. So there we go, 1.7. Joys of an SSD. Here we go. To 1.8. And here we go. We're now into the buffer pool extension. Okay. So we've also pushed some of the AdventureWorks 2014 database down into the extension as well. In fact, we've pushed quite a lot down into the buffer pool extension. It's interesting to see, because it didn't happen in the demo when I tested it this morning. So as you can see, that is our buffer pool. That is in our extension. Okay. So whilst that is all churning away quite happily, you can see our query is still happily executing away. So what am I about to do? Okay. There is our buffer pool extension. As you can see, it's being quite happily used. If we look at our personal encounters, you can see we've got writing I/O down, page writes per second. One thing you'll notice is page life expectancy is still good. So things are being evicted, but they're being evicted down into the buffer pool extension. So what just happened? Well, I'll tell you what just happened. I pulled the USB stick out. So we now have no more buffer pool extension. Our query is still executing. Because we've only got clean pages, and I now have the clean pages on a memory stick in my fingers, we've not had the server go down. It's behaving itself okay. What that means is I should be seeing page life expectancy drop off. Let's come on, back to the buffer manager. Let's just add that one in. Come on. Thank you. That's the wrong one, that's why. Come on, that way. Let's stick the 2014 one in there. 14. Buffer manager. Come on. Okay, yep, there we go. It has finally dropped off and caught up. Sorry, I was being a little bit impatient there. So, whereas before our PLE really wasn't being affected, now, yep, it's fallen off a cliff. So, query's still going, not a problem. If we come back and look at our buffer pool, what does it look like? Well, you'll notice here, it's automatically disabled itself. Okay. Now, in this scenario, basically, as soon as the drive's disappeared, it goes, okay, fair enough, I'm shutting down. So, if you plug the drive back in, it's not, which I'll do now, 1 second. There we go. Okay. There's our drive back. There's our buffer pool extension folder. There's our buffer pool extension file, but doesn't automatically re-enable itself. You have to manually go in and deal with that. Okay. So that is where we are with that one. So what I've got now is what I'm going to do is create that buffer pool extension file, and I'm going to stick it down on my SSD this time. Okay. Now, one thing to remember is if it does fail in that sort of way, you have to do the manual clear up because it won't overwrite or reuse the file. Clear that out. If you try to do it, it will say there's a file existing, but if you shut it down gracefully, it will clean up after itself. Same as when the SQL Server restarts effectively. Okay. So now what we have is, if I just do this. Okay, there's a buffer pool extension file. This time it's on my nice happy SSD, which is firmly plugged into my laptop. There's not much chance of me pulling that one out. So we've also got our buffer pool interop database as well. We've got all the files there. Obviously, I wouldn't look to try and put them all in the same place in production, but I've only got one SSD and one volume in this instance. Okay, so. Okay, I managed to generate an out-of-memory exception on my laptop for the time being. So, right, what we do now is, I'll just clear that one down. Again, we'll just have a quick look. Now we've got it up and running again. Everything. In that short period of time, it's managed to throw some data down into that in buffer pool extension again. There we can see we're using approximately 16% of the buffer pool. You can see how many allocated pages are and how many free pages there are as well. So again, things that you'll want to monitor.
I got a quick tip for you, John. When you use Zoom It,
yep.
and you try to draw the lines, hold down Control, see what magic happens.
Okay, will do. Thank you very much. Okay, so what we're going to do now is I have got in-memory LTP configured for this database. Now, before I do anything else and completely break my system, as I have done a number of times, I am just going to change the max memory setting. Okay. Okay, let's set that to 4096. Just give myself a little bit of breathing room so that in case I add too many rows, I don't make my system fall over. So we've just increased the amount of memory that we're doing there for our SQL Server. So what I've got here is essentially, in this database, I've got a memory optimized table, which is very badly designed, but it's just basically designed so it's going to eat memory. Okay, so it's just an integer identity value. It's going to be ascending, and a char 4000 column, or an n char 4000 column. So that's just going to eat its way through memory for me. Now, the reason behind that is just to demonstrate. Now, if we look at our buffer pool composition again. So you can see we've got about 1.7 gigs in there, 1.5 gigs in the buffer pool extension. So if I select the right database, apologies for that again. Okay, so just inserted 10,000 records into that particular table. As you'll notice, one thing that so we've got that. So I'll insert another. So what we'll do, give me a second, I will just make this quite small. Now if we keep an eye on the counters over here, I'll do this piece by piece. It's the joys of a non-durable table. 10,000 inserts are very, very quick and very, very easy. So we should very soon start seeing spikes in our buffer pool. There we go. You can see we're starting to write things down, and we've just jumped the amount of percentage that we're using. So if we come back to here and execute this one, you can see that we've pushed data out of the buffer pool and into the buffer pool extension just by inserting rows into our buffer pool into our in-memory table. Sorry. So what does this look like on a graph? So I'll just insert another 10,000 rows, and I've used up all my memory. Okay. Okay, it says I haven't got sufficient. Okay, so I've run out of memory for my in-memory LTP. But again, like you see there, we saw as it went through, it pushed data out. Let's see if that will work this time. No. Okay, so I've run out of. I've hit the limit for my in-memory configuration at this point in time. So basically, the point I was illustrating there was essentially things are being paged out of the buffer pool as more pressure comes in from, in this instance, in-memory OLTP. So if you're using in-memory OLTP, it's generally advisable, in my view, to look at configuring buffer pool extensions to give you that bit of extra sort of support when it comes to dealing with the amount of memory contention you're likely to see in that system. So we'll get rid of that, and we'll move on to the next demo. Okay, so equals, I think it's database ID 9. So yep, here we go. So as you can see, we've got a nice sort of distribution of pages for our database that are either in the buffer pool or are in the buffer pool extension. So if I grab that back, okay, what we'll do is we'll have a look at the pages. So let's pick a couple of pages. We want that data page. So 604.726. Okay, what we'll do here, and we'll have this one here as well. So 362.399. So as you can see, we've now got one page in buffer pool extension and one page not. Now just be aware, as you can see, when it's in the buffer pool extension, you do lose some information. Okay, so just be aware of that. So what are we going to do? Well, we're going to find out which records are on our pages, and we're going to ask for them again. So that's our buffer pool extension page. This is going to be our page for in memory. So that. So what we're going to do is going to use dbcc page to hunt down sales order ID. That's what I'm after. So what we'll do is we're going to go in and we're going to query it, and we're going to say, bring me back the value for, basically bring back that page. Okay. So we'll do the same this time for the one that we've got that's in memory. That's what I want. Okay. So one of these pages is on my SSD. One of these pages is actually in the memory. So just double check, make sure nothing untoward has gone on. And I've just run the wrong query. Apologies for that. There we go. So we've still got that one in the buffer pool extension and that one in main memory. Okay. So what happens when we query them? Really helps if I'm in the right database again. So we've queried them. We've got the data back. How long did it take? Okay, as you can see, we are looking at the second one here is negligible time overall. So when you think I've got this on an SSD rather than in memory, the time is still very low. The latency is very low to actually go and get this data back. Now, as I said earlier, because we've typically when you query a page, you expect it to go back up into the buffer pool, but it has remained in the buffer pool extension. So basically, as I said, the only way to get that out of the buffer pool extension is essentially to perform an update on it. So you've got to force it back up. So if you have got pages there, it's not a case that it's going to go down to disk. It's going to do the retrieve from disk, place it in buffer pool, and what have you. It will. So let's do this. Sales order header set order date equals, so get UTC date, where sales order ID is equal to that. Now, in theory, if the demo is behaving itself, did I update the wrong one? Yes, I managed to update the wrong one. I want that one. Apologies for that. So, there we go. So, it's been updated. We can see it's modified. Obviously, if we tell that to get a move on. So, apologies for the delay. I should have written down by now. Okay. Right, whilst we're waiting for this to happen, have we got any questions at all? Nico?
We do have one question from Suresh Ravi, who unfortunately left us. And he says our max memory is sometimes around 60 gigabyte. So does that mean I need to have buffer pool greater than 60 gigabytes in that case?
The buffer pool extension will need to be greater than the system configured memory, yes.
Okay, so you can never add a buffer pool extension which is smaller than the configured memory for the server.
No, not at that given point in time.
Okay.
Right.
Okay.
That's one thing I will do is let's say we want times 16. Okay. Sorry, my math is not what it should be, so I want that much. Okay. What we can do. So what we can do is this, but just be aware that that will. So you can, in theory, end up starting with your memory low, create a buffer pool extension. You can then increase your memory load back above your buffer pool extension. As to whether or not this is advisable, I would say Probably not. Like I say, typically our recommendation is 4 to 10 times the size of memory, depending on what your workload is. And what you're looking to do really is to try and sort of give you that extra capacity that you're after. So if you've got, say, as the question was, 60 gigabytes worth of memory potentially, how much benefit is an additional 20 gigs worth of buffer pool extension going to give you? So think about that. Okay. And with that, that's the end of these demos. Find the PowerPoint again. Has anybody got any questions about anything that we've covered so far?
So I think we answered all the questions from the attendees, but I have a question.
Yes, of course.
So there's been a lot of debate about probably you read some recent blog posts and recent presentations about the true value of the buffer pool extension in enterprise systems.
Yeah.
And so I'm wondering if you have any benchmarks that you did and some numbers you can give us. And again, I do realize that, you know, it's very, very workload specific, and different workloads will have different characteristics and different results. But if you can tell us about some benchmarks or some actual production implementations that you did, and what, you know, ballpark figure range of improvement you got.
Unfortunately, I can't. The work I've done has been with customers has been testing, verifying. In each situation, what they've resorted to is basically putting more memory into the server. For their workload, everything we tested, for the customers that I've dealt with, and I can count them on 2 hands, that have been looking at this one, because people are still finding their way with 14 at the moment. There's still a lot of testing going on, specifically related to things like the query the new cardinality estimator is, meaning that adoption requires a lot more testing than normal. But where they've been dealing with large enterprise servers, it's typically been a situation where if they've got a big server and they're doing a very heavily OLTP workload, they've got the provision and they've typically spec'd the servers already before they've looked at buffer pool extensions. I haven't got anything in production at the moment that's using them. Again, if you can afford the memory, go for the memory. It's going to give you more performance. There was a good blog post written by a member of the community that did some benchmarking, and the numbers that he came up with were very similar to the sorts of things that we were seeing with some of the customers that I've worked with.
If I might add here some input, actually what I've seen so far, it corresponds to what you told us, but it also, I would not forget the standard edition where you just kept 100.
Yeah, I mean that's where, I mean, unfortunately, a lot of the customers I deal with are all enterprise edition. I think we're going to see more of it in the standard edition side of things than, as you say, than we're going to see in enterprise, because we've got that 128 gig cap on memory.
Yeah, that makes sense.
Here. Sandeep Sajdev. So his question is, given a choice between using SSD for TempDB versus buffer pool extension, what is the recommendation?
It depends on your workload. If you're not using TempDB heavily, you will see limited value potentially of putting TempDB onto an SSD. If you have got a very TempDB heavy workload, but it is very, very workload dependent in that scenario. Obviously, if you're using things like snapshot isolation and such like that, you're going to be using the version store in TempDB, and you've got enough memory that you're not using. A lot of it's, I'm going to shoot myself in the foot here with this one, but a lot of it will relate to your PLE and the effect that that is having on your system. Now, I'm not going to sit here and say that you need to have a page life expectancy value above X. When you talk about page life expectancy, I think the best way to view it is, okay, the value of X is meaning that I drive Y proportion of I/O. So if you've got a page life expectancy of 3,000 and you've got a buffer pool where you've got 20 gigs worth of data, you basically do the 20 gigs divided by the 5,000, how much I/O is that driving, megabytes per second or what have you, and then take that value and work out what percentage of your I/O subsystem capability you are consuming in order to maintain that page life expectancy value. Now, if that is 5% of your I/O subsystem capabilities, and that's what your standard workload is, then yeah, you're potentially going to see limited value with buffer pool extensions. If, however, your page life expectancy value means that you are effectively driving 50 to 60% of your I/O subsystem channel capability, in that situation, you might see benefit by having buffer pool extensions in place to help increase that and lighten the amount of I/O load that you're seeing on the main channels down to the data files. Obviously, it will depend where you've got your data files. If they're on the local server behind the same RAID controller you're going to be putting the SSDs into, then you need to consider there's a potential bottleneck there as well. So, sorry I can't give you a definitive answer in that situation. It is highly workload dependent.
Yeah.
But yeah, if you're driving, go ahead.
There is a further question, but please finish your answer first.
Yeah, I mean it's really like I say, if you're driving a lot of I/O because you haven't got enough buffer pool memory, then yeah, you're likely to see a performance improvement. But again, it's going to depend on your workload. If it is a very write-heavy workload, you will have a very, very limited impact use of buffer pool extensions. It's one of those features, as you said a minute ago. I think the key element is the fact that it exists in Standard Edition and BI Edition, and that's where you're going to get most benefit if you're using one of those two versions, I think.
All right. So the next question is, why is there performance gain on the read-heavy OLTP but limited for data warehouse workloads?
Good question. Typically, it depends what you're doing with your data warehouses. Depends on the amount of data you have. Typically, you're talking very, very large amounts, yes. If you're an enterprise edition, you need to really sort of have a look at something like column store. That can really sort of help you out there more than, say, buffer pool extensions would. Whether or not it would work well with Standard Edition, it's not something I've looked at. A data warehouse, a small data warehouse in Standard Edition, it's not something I've really considered. So it's something I might have to go and go away and look at, thinking about it. But typically, like I say, the data warehouse is the types of stuff that you're doing. Obviously, you're going to do your high scan rates, and if you've got Enterprise Edition on your fact tables there, column store can add a lot of benefit in some situations. So, sorry I can't give you a good answer on that one either. I will actually have to go and look at that one and see what sort of workloads we get. Because yeah, it depends on your query workload really, I guess. If you've got a lot of queries going in and hitting the same couple of tables and the same ranges of data, yeah, potentially you could see an improvement. Again, if you're looking at doing something like that in Standard Edition, potentially if you can get your dimension tables up into the memory pool as well, yeah. I'll have to go and explore that one, and I'll see what I can come up with.
Okay, great. More questions? We've got like 2 minutes before the end of the webinar.
Mm-hmm.
All right. So if there are no questions, then thank you very much for attending our renewed launch of the in-memory virtual chapter. Hope you enjoyed this great session by John, and we hope to see you very soon in one of our nearest webinars. Thank you very much.
Yeah, and remember to go to imvc.sqlpass.org and register so we can let you know in an email just before we have a new session coming so you can plan. And look us up. We have a Facebook page. We have a Twitter account. You're more than welcome to join, like, and follow us on Twitter so you'll get up-to-date information. And thank you very much, John. It's been an enlightening talk. And
That's right.
yeah, it seems like a really exciting new feature.
Mm.
And again, just my personal guess is that once the feature matures, it'll probably have smarter algorithms of, when to transfer databases and predictive caching, that sort of thing. So we're bound to see much more of this feature in the future, right?
Mm-hmm. Yeah, and like we say, it's just remember it's there in standard edition too. It's not an enterprise-only feature.
Yeah, that is great, and that is unfortunately rare for nice features recently in SQL. But anyway, thank you very much, John. Thank you very much, everybody. Hope you enjoyed it, and see you next month. Ta-ta now. Bye-bye.